Okay, so in this question here, we want to solve for secant in the, these are two circles from 2 pi to 3 pi. So that's beyond the first circle. It's like beyond the first circle and only the first half of the next circle. That's beside the point right now. So what we want to know, well, I was going to write that in there. So this is from 360, because that's going to be important for determining the angles within the domain here. So 360 and 540, I believe. Yeah, 540. Okay. So I'm going to try to solve this algebraically here. And to solve this algebraically, I'm going to set up a let statement here. So I'm going to replace all my secants with x's. So I'm going to get a statement that says x squared plus x is equal to 2. So x squared plus x minus 2 is equal to 0. And then I'm going to factor this out. So x and x. 1 multiplies out to negative 2 and adds to 1. So that's 2 and negative 1. So I have x is equal to negative 2 and x is equal to 1. And then I'm just going to use my let statement there and replace x's with secant again. So I get these two statements. I get secant is equal to negative 2 and secant theta is equal to 1. So I'm going to have to solve for both of these. Now, if I remember correctly, that secant is the same as 1 over cos. So that means this is going to be cosine. So go to 1 over negative 2. And the other one is going to be cosine is equal to 1. Now remember, cosine is equal to the x value. So if I were to plot this out, where would my x values be? 1. So x value would only be 1 in one situation, would be right here, positive 1. So it's right here. This is where the x value is 1, my y value is equal to 0. So 0 degrees. Okay? So I'm going to write that there. That's not within my domain at this point. But I'm just going to write that down for now, because it's not between 360 and 450. My next one here is when cos is equal to negative a half. If I use my add sugar to coffee rule, cos is negative a half in this quadrant and this quadrant. Okay, in those two quadrants. And the reference angle here is going to be 60 degrees. Okay, so we have 60 degrees. So yeah, theta is equal to 120 degrees, because that's 180 minus the 60, and 240, which is 180 plus the 60. Okay, now none of these angles actually match because these are they're in the first circle, but the answers has to be beyond the circle between 360 and 540. So what we're going to do is we're going to find coterminal angles of all of these and see whether or not they land in the quadrant. So what I'm going to do is going to add 360 each one of these. I'm going to plus 360s to all these. And I get 480, 360 plus the 2, that ends up being 600. So that's beyond my domain. I'm going to write that down anyway. And if I add 360 to this one, because we've got equal signs here, so that's important too. Add 360 to this, I also get 360. Okay, so I'm going to cross off the 600 because that's beyond my domain. So 360 matches my domain because I can be equal to 360, and 480 is between the two. So these two answers work. So I'm going to just change those back into radians. So I'm going to go 480 divided by 180. Math, enter. I get 8 over 3 pi, and 360 is 2 pi. There you go. So those are my two answers for this question. Not too bad. Here they just want us to state the general solution of this one. They kind of give us a nice little picture. It looks pretty good. There's lots of different general solutions to this. I'm going to write the simplest one. I'm going to write this as 2 statements rather than 3. There are 3 angles. That's fine. There's 3 angles. You can write down 3 solutions. But you can combine A and C together because they are on a straight angle, so they're 180 apart from each other. Okay, so to write out my general solutions, it's best to write my general solutions out. with positive principal angles. So this angle here will be 3 pi over 4, right? Angle B is pi, and the other one, which I'm not going to use, but I'm just going to write it anyway, was all the way around here. What does that end up being? 7 pi over 4? Let me just double check. Yeah, 7 pi over 4. Okay, so I know all the standard principal angles here. So angle A, so if I use angle A here, which is the 3 pi over 4, it would be 3 pi over 4 plus 2 pi NEI. Okay, that's the first general statement for angle A here. Okay, for angle B, I should probably put down equal to theta. What the heck is that? Okay, that's better. We're going to principal angle plus 2 pi NEI. Okay, and for angle C, it's going to be 7 pi over 4 plus 2 pi NEI. Now, A and C, they can combine together. So A and C can turn into theta is equal to 3 pi over 4 plus pi. Oops, I keep forgetting the ends here. And oops, should be an n here. N should be pi n NEI. Okay, then I can just jam B back in there. So these two statements, 2 pi, are my answer there. Okay, so I can combine A and C together if I needed to. Now, the left side's fine, the right side's fine, doesn't matter to me. Right, they're both correct. Which of these are coterminal to 30 degrees? So 30 degrees is pi over 6. I'm just going to change it to that, which is 1/6 pi. Okay, so I'm just worried about the 1/6. So I'm just going to go 1/6. Let's do some positive ones first. I'm going to add 2. Math, enter. 13 over 6, that's not quite in there. I'm going to add 2 again. Math, enter. 25 over 6. So I actually do get one down here in the positive side. It says which of them is coterminal. So that one there is coterminal. So I'm just adding 2 each time. So I'm taking this plus 2 pi, which is just going to be pi over 6. Or sorry, 1 over 6 plus 2. So I'm just worried about this piece here. If that didn't work, then I just keep on adding 2 and add 2, add 2. Or subtract 2, subtract 2, subtract 2, right? You just keep on doing that until you find one that matches. Math, enter. You always put the pi back in if you need to. Good estimation here. So this is supposed to be in radians. It looks like it's all in radians here. So remember the top here is pi over 2. This is pi, 3 pi over 2, and 2 pi. Okay, so it looks like kind of 45 in the third quadrant. Remember that this pi is 3.14159-ish, right? So it's got to be bigger than that. So I can get rid of A, I can get rid of B. And I just want to quickly type in 3 pi over 2 in my calculator and get 4.7. ... So D is too big. So the only one that kind of fits within that range of 3 to 4.7 is 4.01. Mary's given this diagram. I think we've seen this diagram already in a previous question. Maybe not, I can't remember. She's been asked about a couple of these statements, and 2 of them are correct. It says 2 statements are correct. So I'm just going to look at this equivalent rotational angle. I'm just going to double check is 120 the same as 4 pi over 3. And I already know it's not, but you go 120 divided by 180, math, enter, that's 2 pi over 3. So statement 2 is wrong. The angle is actually 2 pi over 3. Okay? The radius of the circle to the nearest tenth is going to be this. So I'm going to have to use my 2 pi over 3, which we just found. All right, so that's my theta in my formula. A is equal to r theta. So I'm going to take A divided by theta. So I got my A, 40, divided by this 2 pi over 3 number. So you get 19.01. Yeah, so this statement looks pretty good. Right? Technically, by doing statement 1, you have to do statement 2 first to double check that. But I know statement 1 is true. Statement 2 is not true. If the arc of the circle is increased to twice what it was before, I should have twice the angle. That is a true statement. You can double check that. Yeah, you can just double check that if you want to. Mary can determine the radius by dividing the angle by the arc length, but here we have the arc length divided by the angle. So r is equal to a over theta, right? So that's a wrong statement. So if you just jump down to that one, even though that one's wrong, then it'd be 3. So 1 and 3. Okay. Here's a couple of exact angles, 17 pi over 5. Well, this is fun because these two angles, the reflex angle is the one that's bigger than 180. And then this other one, if I add those two angles together, what should I get? Well, I should get a full circle. So I should get 2 pi. So I'm going to rearrange this. That's what I'm going to do because they all have pi's in them. Is just cancel the pi's out. It makes the math a little bit easier for us. Most of the time we don't deal with the pi's, we just kind of put them back in after the fact. So this is going to be a over 15 is equal to 2 minus 17 over 15. Okay, so 2 minus 17 over 15. Math, enter, 13 over 15. Okay. 13 over 15 is equal to a over 15. A, look at that, a is 13. Okay, the length of r in the same question. So they give us a kind of an angle there, or sorry, they give us an arc length here that corresponds to this angle. So a is equal to r theta. R is equal to a over theta. A is 34 pi. And this one's 17 over 15 pi. So again, because I'm dividing both these by pi, I can get rid of the pi's. So it's really just going to be 34 divided by 17 over 15. So it ends up being exactly 30 something, 30 units, whatever. It ends up being exactly 30. Cool. They want us to know the angle between A and B, angle theta there. Okay, so let's just first of all figure out what the angles are for both of these. I think this question was kind of done before. I think we did this question, but we did it in degrees. Here they want to do it in radians. So let's redo this question. Here the y value for A is a half. That's my sine. Remember, that's what my sine is. So let's call that sine A. So sine A is a half. That means this angle is 30 degrees. Okay. Both of these are the same. So that means this is 45 degrees. So I'm going to go 180 minus the 30 minus the 45. Yep, sounds very familiar. And we get 105 degrees. So I'm just going 180 minus the 45 minus the 30. And I got 105 degrees. This is 105 degrees here. Then I'm just going to change that into radians. I'm going to divide it by 180. Math, enter. Get 7 pi over 12. Okay, so that means 7 on the top, and n is 12. So 12 on the bottom. So 7 and 1 and 2. Okay, so what we know about this point, it lands on the unit circle, because it has a radius of 1. So let's just do the math on this. I'm going to have 1 squared is equal to x squared plus y squared. That's the formula. We have the x of 0.2 squared. 1 squared is just 1. So y squared is 1 minus 0.2 squared, which is 0.04. So 1 minus that answer is 0.96. And then I'm going to take the square root. That's all they want. They just want to know what is the value of b, what's underneath the square root here. So they're just looking for the 0.96 number, just what's underneath there. Cool. So this is, so they give us some information about this. So this is a sine is positive. So what I know about sine being positive, it has to be in the first quadrant. And add sugar to coffee. It's got to be in the first and the second quadrant. So it's got to be in this too. But the thing is, it's also saying that tan is a negative number. So tan is negative in the second quadrant and the fourth quadrant, because it can't be negative in the all quadrant and it's positive in the tan quadrant here. So because it is positive and negative, it has to land in this quadrant. It can't be this one, or this one, because it has to be positive and negative at the same time. Okay? Now, there's two ways to do this question now. If you treat this as if this is on the unit circle, because it does say it's on the unit circle, you could just say that's my y value, right? So you could just say that my y value here is 7/10. But because all triangles are similar, they all have the same ratio, they have the same angle, I could just say that's my opposite over my hypotenuse. But we're saying it's on the unit circle, why not? Say it's on the unit circle, that's going to be 1. So I'm going to cross off the two positive answers, because the x value has to be negative if it's in this quadrant. So I have to determine out of these two which is the correct one. So we're going to use our Pythagorean theorem here. 1 squared is equal to 7/10 squared plus x squared. I'm going to rearrange this. So we get 1 minus 7/10 squared is equal to x squared. So 1 minus 7/10 all squared. Then go math, enter, and you get 51/100. You take the square root of both sides. Don't really see what answer it's going to be in 2 seconds here. (51/10). So the A. You just jam the negative back in there because it has to be going backwards. Cool. Okay, so this point lands on the unit circle. Okay, you can double check that. You can go 1/13 squared, or sorry, 5/13 squared plus 12/13 squared ends up being 1. So that is on the unit circle. So you can draw that out. So what I am going to actually draw this out. So this ends up being on the unit circle with a negative x and a positive y. So it's in this quadrant somewhere over here. It's on the unit circle, so the radius is 1, my y value is 12/13, my x value is negative 5/13. Then we're just going to find all the 6 trigonometric ratios. So sine is, and what are we doing? Sine theta. Yeah. Sine theta. Here's theta. Sine theta is just the y value, so that's going to be 12/3. Cos is just the x value, which is going to be negative 5/13. And tan is going to be y over x, so that's going to be 12/13 over negative 5/13. So 12/-5. Cool. Now all the reciprocal ratios are going to be cosecant, which is the reciprocal of sine, secant, which is the reciprocal of cosine, and cotangent, which is the reciprocal of tangent. There you go. That's pretty good. Given that cosecant is this. That's nice. They give us a picture. They didn't have to give us the picture here. What if they didn't give us the picture from the information down here, we could have figured this out because cosecant is the same as sine theta is equal to 5 over 8 opposite over hypotenuse, and that's what they labeled in the picture there, opposite and hypotenuse, and it's in the second quadrant because it's past pi over 2. It's pi over 2, and here's pi. What's the exact value of tan? Okay, so tan, I'm going to have to determine what the x value is. So we have to go 8 squared, is equal to 5 squared plus x squared. So 8 squared is 64 minus 25, I get 39. Take the square root. And I get that. And I know it's negative. X is a negative number. Okay, so tan theta, I don't think we can take any numbers out of this. No, it doesn't look like it. I was thinking we could create a mixed radical. Tan is going to be y over x, so that means it's going to be 5 over negative root 39. So I'll just write it with a negative on the top instead. There you go. Looking pretty good. What page are we on right now? Over page 18. 23 here. Getting there. Here's slowing down a little bit. Now the exact value of this one. We did something very similar to this, as we just have to determine from the inner circle what is sine, and pi over 6 is 30 degrees, so I know that this is going to be a half, but because it's negative, it lands in this quadrant down here because it's going downwards negative 30 degrees. So add sugar to coffee. My y value, because remember this is the y values, and these are x values. My y value is negative here, so this is going to be negative 1/2 to start off with, right? Cool. And 7 pi over 4, 7 pi over 4 is a 45 degree angle because it's over 45. 7 pi over 4, let's just times that by 180, 315. So that lands in the fourth quadrant again. 315, 45. So x, and this is y. My x is positive, and this point here, if you remember this point, would be either root 2 over 2 or 1 over root 2. It doesn't really matter. I'm just going to put this point down here too. This one would be 3 over 2 and negative 1/2. Okay. I'm just worried about the positive, so this is the x value, so this is going to be plus root 2 over 2. They both have a common denominator already, so I'm just going to add those together. Let's put the root 2 in front minus the 1. So it looks like it's going to be a in this one. Tan is 5 over 2, and it's in the circle, and then the largest positive value of theta to the nearest tenth of a radian is, let's figure where tan is positive. So tan is positive. Add sugar to coffee. It's in positive in these two quadrants. So my largest theta in the one circle was going to be the second one here, the one in quadrant 3. This one. Okay. So to do this, I'm going to find out what my reference angle is first of all. What? Don't know why I just wrote that over again, but I'm going to go tan theta or tan inverse 5 over 2. Tan inverse 5 over 2. I get 68 degrees. Now I could just do this in radians. Maybe I'll just leave it in degree mode on my calculator. I like to leave my calculator in degree mode. I don't want to change it just in case. So I get this kind of angle here. My theta that we're worried about is the larger one of these. So I'm going to go 180 plus this angle, get 248. There are two answers, right? There's this other one, the 68.19, number 2. But I'm just worried about the bigger one, and I'm going to just change that into radians. So I'm just going to write up my ratio here to figure out what I'm doing again. Sometimes I forget. Yeah, cross multiply, divide. Okay, so I'm going to times by pi divided by 180. So to the nearest 10th, all right, 4.3 rads. Should go to 100th on that one. Could be a little bit more precision. Because it's 4.33188. Dot, 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 dot. Which one of these are undefined and which one's a 0? Now, the thing is, the regular ratios I can do pretty easy. Like, what's tan 90? Tan 90 is undefined. So that's a good one. Sine pi, let me just quit this out. Sine, that's 180. So my calculator is in degree mode, so I'm just going to use my degree mode here. So I'm just doing the regular ratios first. Now, the reciprocal ratios are a bit tricky to do. Are they undefined or not? Because the next one here is going to be for the cotangent one. So we 1 over cotangent. Let me just put that as 270. Now, tan 270 is undefined. It's an error. But the reason behind that is because it's 1. That's technically negative 1. Is it negative 1? Yeah, it's definitely negative 1 because it's going down over 0.
Interruption. We just had a report that there's a Hyundai in our staff parking lot that still has your lights on. Sorry, I don't know the color, but there's a Hyundai in the parking lot with lights on. Thanks.
Okay. The reason you get an undefined part because it's going to be negative 1 over 0, and you can't divide by 0. But if you simplify this down first, it's going to do a reciprocal over, becomes 0 over negative 1. So the answer is technically 0. Oh, I don't know why I put a 2 here. Oh, yeah, 2 is undefined. This is not 0. You get a value of 0, you put a 1 here. Okay. So I get a 0, so I'm going to put a 1 there. Okay. Now, sine. Now this one here, you're going to run into the problem. This is going to be sine 360. Sine 360 is not some weird ratio, it's just 0. So I'm going to run into 1 over 0. So I get an undefined in this one. So I get undefined. Yeah, so this is the trickier one here. Like, if you have a fancier calculator that has a cotangent button, or go to decimals, you can actually type that in. It actually ends up being exactly 0. Right? Even though your calculator can't do it, you can't go 1 over 1070 in your calculator. You could do it on other things too. So here, I'll show you what it looks like. Decimals here. Yeah, so on decimals, I go cotangent 270, you get 0 degrees. So you have to make sure if you're in radians, it doesn't quite work, but if you want to put it in radians, you can. Cotangent 3 pi over 2. So I get 0, right? But if I try to type in 1 over tan 3 pi over 2, well, I actually get 0 too. Smart enough to know what to do there. Your calculator can't do it, but this one's apparently smart enough. Cool. Okay, so we have these angles, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. That's a lot of angles. Are they all part of this solution set here? Like, I'm just looking at number 2 here. First of all, let's look at the top one there. There's only one of these statements is true. Are they 30, 150, 210, and 300? I don't like that 300 there. It is a 30. Pi over 6 is 30 degrees. Yeah. So they're all going to be within that 30-degree reference angle. So I can see that 5 times 180 divided by 6 is 150. 7 times 180 divided by 6 is 210. But 11 times 180 divided by 6 is 330. So statement 1 is incorrect because this angle is 330 degrees. Okay. Now this general solution is just saying that what if I went 30 plus 360? I get 390. Now they're all part of this solution. They're not, because it's going to go 30, 390, 750. It's skipped all the numbers, so this is not going to work nicely. All right, so this doesn't give me all the solutions. This gives me pi over 6, and then it gives me my next one if I wanted to do this way. The next one is 13 pi over 6. So it skips all the numbers, goes right to one circle later. So that's not, doesn't work, right? I don't know what to do here. Okay, so it doesn't work. Are they both negative? So my calculator here is in degrees. So 7 pi over 6 we decided was 210. So sine 210, negative half. Awesome. Cos 150, because that's a 5 pi over 6, is negative. Yep, they're both negative. That's just the easy way. You could do it like a unit circle. I don't see why you do that. Here we are. We want to determine the values or solve this one. Now you could solve these, like this is multiple choice. You could just solve these graphically if you wanted to, but I'm solving these algebraically. So I'm going to factor out the cos. Remember, when you factor out, you're dividing. So cos divided by cos is going to be 1. And then you're going to solve both of these. When is cos equal to 0? And when is cos equal to negative 1/2? So cos, remember, is the x value. So where on the unit circle is my x value equal to 0? On the unit, it's equal to 0 when it's straight up and down. Right there. So between 180 and 360. So my 90 degree, I'll just cross those off because they already have answers there beyond the domain. So only between 180 and 360, just the bottom half. 90 degrees would be an answer for the full circle. But we have 270 as well. Looks like B is going to be the only answer there. Let's just double check if 240 lands in where we need to be. So cos is negative in the add sugar to coffee realm. So it's here and here. So these two angles. Now, the only angle that really works here is going to be this one on the bottom. And the reference angle is 60 degrees, I believe. Yeah. So that's going to be 240. Yeah, so 240. Actually, I'm going to write both my answers down here. So I get 120 and 240. Beyond. So this is my answer. Here I get 90 and 270. I'll cross up the 90 because it's beyond my domain. Cool. Now, this one here, they did the most common mistake here. It's like, oh, both sides have a cos in them. Let's just divide both sides by cos. You cannot just divide things out when you're solving for them because then you lose your solutions. Like one of my solutions here would be if cos was equal to 0. Well, we don't have that. When you get to the bottom, it's cos equal to 1. So you've lost some of your solutions in step 2 here because you divided. I'm just going to write this down. Cannot divide out factors when solving. When simplifying, yeah, sure, just simplify them out. That's what it simplifies down to. So you'll have like holes in your graph and stuff. You'll have like, what do you call those? Points of discontinuity and stuff. But you cannot divide out factors when you're trying to solve them because you're going to lose your solutions. Like if I were to solve this now, let's say I was going to try to solve this. Also another mistake here. This is also a mistake here. But the first mistake he makes. It's going to make a lot of mistakes here. Cosecant is not cos. It's 1 over sine. So what I would do to solve this one is change the 1 over cosecant into sine. So 1 over cosecant is just reciprocal of sine. Reciprocal just turns out to be cos theta. This would be my first step. Cos theta sine theta. Now I'm not going to divide anything out. I'm going to make this equal to 0. I'm going to minus over the cos theta. What I'm going to do now is I'm going to factor out cos theta. Okay, then I would have two solutions here. Or I have multiple solutions. I have when cos is equal to 0 and when sine is equal to 1. So I'd solve both of those things, and I get totally different answers here. So cos would be 0. We already had that one before. In a full circle, cos equals 0 from 90 to 270. So theta would be 90 and 270. And when sine is 1, sine is the y value. Oh, that's 90. Okay, so this should just be my answer. There's overlap between my answers here. So 90, 270 from the cos 0, and then sine 1 would just be 90, so that's just repeated. Anyway, that's beyond the question. I made multiple mistakes there. What's the general solution for cotangent squared is equal to, cotangent squared minus 1 is equal to 0. So let's solve for cotangent theta. So we'll take the square root here. I'll just keep doing that. Okay, so I take the square root of 1. Remember there's a plus or minus here because we took the square root. Plus or minus. So tan theta is equal to plus or minus 1. So where is tan theta equal to negative 1 and positive 1? Well, it's equal to negative 1 and positive 1 in all 4 quadrants and at 45 degrees. If I do my tan inverse here, my reference angle is 45 degrees. So 45, 45, 45, and 45. Now, if you look at these very carefully, they're all 90 degrees apart from each other. So if I were to go from here to here, that's 90 degrees. 90 degrees. 90 degrees. So what I can do here is I can put all of these together as one general solution, where I start off with I want this in radians. So this would be pi over 4. So I start with my principal angle, so pi over 4, plus 90 degrees. 90 degrees is pi over 2, n e I. So I can just combine it together as one thing, which is nice. This one here, it says solve this one graphically. You can solve this one algebraically too. It's very legit to solve this in algebraically. It's probably be almost just as easy to do that. So I'm going to solve this algebraically, and then I'm going to verify it graphically. See if it works. I want it from 0 to negative 180. Those are my things, but I'm going to solve in the first circle and then deal with coterminal angles later. Okay. So 2 minus, I need this to be 0. So I'm going to rearrange this to be 0. So I'm going to subtract over and divide. So I get secant is equal to positive 2 over 3. I'm subtracting over and then divide by a negative. So 2 negatives make a positive there. Secant is cosine. So it's going to be root 3 over 2. Okay, so where is cosine positive root 3 over 2? So cosine is positive root 3 over 2 in the first quadrant. Right there. And in add sugar to coffee in the second quadrant. Down here. Okay. So the reference angle for this is 30 degrees. Remember, you can just take the cos inverse of that, and that'll get you that 30 degrees that you want to find. So my two angles right now just for the first circle, it's going to be 30 degrees and 330. Okay, let me just double check those. Cos 330, yeah, that's the right number. Cos 30, that's the right number too. Those are not within my domain. I want to go from negative 180 to 0. So I'm looking at the bottom half of this circle, from 0 over to negative 180. So I just want the bottom half of a circle. So I'm going to just find some coterminal angles. I'm going to subtract 360. 30 minus 360. So I'm going to minus 360. So 3, nope, that's too far. But if I go this, I get negative 300, or negative 30. So that angle works out nicely. Looking good. Then the next one over here is I'm going to go secant theta is equal to negative 3. So that's this one here, right? Secant again, remember, is equal to cos. So it's equal to 1 over negative 3. So it's just negative 1/3. Now it's not a nice one, just like it's not the same as the one on the left here where you got this exact answer. So I'm going to find my reference angle. Cos inverse 1 over 3 gets me 70 point some degrees. So 70.528 decimals degrees there. Where is cosine negative this time? Because before it's positive. So it's negative in this quadrant and this quadrant. And we're just going to determine the angles in standard position. So I'm going to use the 70 degrees as is. I'm going to find in the first circle and then kind of back it up to see can I find coterminal angles within that domain up there. So 180 minus this answer. So I have 109.47-ish degrees and 180 plus this angle, 250. Okay, so I'm going to minus 360 from both of these and see do they land in with that. So now I can see that one's not going to do that because it's in the top half. If I minus 360, it still lands in the top half. So this one's not going to work. I'm just still going to do it. Why not? I get negative 250. No, too far. And then the 251. What do I get? Negative 109, I think it is. Let me just double check. Yeah, negative 109. Cool. That's with the domain. Now, you can graph those. You can verify it by using graphing technology. Just whatever you want to do. I'm happy with that. Math 31, blah, blah, blah. Determine the blah, blah, blah. Provided 4 different solutions. Which ones are correct? Remember, there's multiple ways that represent the same thing. You can combine certain ones together. You can keep them all separated. That's totally up to you. So first of all, I want to solve this. So I'm going to look at that. I'm going to factor out what they have in common there. So I'm going to factor out that cos theta. So 2 sine theta minus 1 is equal to half. So cos theta is equal to 0, and sine theta is equal to 1/2. Okay, so where's cos? Remember, cos is x. So where's the x value equal to 0? So it's equal to 0 at 90 and 270. Okay. Cool. Okay, I'm good at that. I'm going to draw this up because it's nice to draw them out. So at 90 and 270, my x values is 0. Now, the reason I want to draw that out is because I want to see how they relate to each other. So I got 90, then 270, and then whatever. So they're always 180 apart from each other. So one of my answers is going to have to be 90 plus 180. That's probably going to have to be in there somewhere. So kind of looks like 4 could have been correct because he's got the 90 plus 180. Ooh, I don't like this one. 90 plus 360. I don't like that. So I don't think question 2, I don't think student 2 is going to be good. Maybe 2 will be good. Look at his other solution over here. Okay, let's double check. For this one, I'm going to draw where sign is positive. It's add sugar to coffee, so he's in the first 2 quadrants. Okay, I'm going to draw that red because I like drawing this. So there's that. I don't think I can combine this as one solution. So I don't think student 1 is going to be correct here. Let's see. My reference angle is 30 degrees. So I got 30 degrees and 150. So let's see how I can combine these together. So let's say I put this together. I would draw this out. Now I like to do this when I draw this out. I just want to see what the pattern looks like. So I've got 150, 90, sorry, 30, 190, 150. And so these are my 4 angles kind of drawn on one thing. Now, the reason I did that is because I could see a pattern here. From the 30 to 150, that's 120. From the 150 to the 270, 120, 120. So all of that is always 120. So I combine those 3 into one piece. 30 degrees, 120, 120. So student 2 did a good job. Yeah, he's got 30 degrees plus the 120 plus 120. This is good. I like that. But he's got that one going straight up. So he's the 90 plus 360. So that is good. So student 2 did a good job here. So let's cross off those top 2 because student 2 is not in there. Student 1 did a bad job. We can't. There's no 60 degrees to start off with, so not good. So same thing here. Student 3 has a 60 degrees in here. Where does that come from? I'm just going to cross that off. Don't even know where 300 comes from. Student 3 just did a bad job altogether. Just get rid of student 3. So this was nice. Got 90 plus 180. Okay, so that just combines these 2 in the first one, the 90, 271. So I like that. Well, by process elimination, 4 has to be right answer. Let's just double check in here. 30 plus the 360, that's just coterminal. And 150 plus the 360, that's just coterminal. Yeah. So both of those. So yeah, I'm going to say 2 and 4 are correct. Looking good. I left this one on here, the last one, because it looked like it's something that we could do. I don't know actually if it is. It probably is something. Let's just see what we can do here. So we are using logs here, so I just want to figure out what k is so I can solve cosecant k, because that's the whole point. So what is k? So let's change this into exponential form. 2 to the power of half is equal to k. So k is root 2. Oh yeah, makes sense. Okay, so now this looks good. So we can actually solve this. So 2 sine theta is equal to 1 over root 2. The reference angle is 45 degrees. I'll leave it in degrees because that's nice. It is positive in the first quadrant, in the add sugar to quadrants, first 2 quadrants, add sugar to coffee, 45 degrees. Okay. So theta is 45 degrees and 135 degrees. Okay, so they want from 90 to 270. So they only want from the left half of the circle. Okay, so the left half of the circle does not include the 45, only the 135 here. Yeah, let's put the 135. Yeah, so that was a question we could do. Cool. There we go. I'll see you in the next video. Bye.